In this video, we want to talk about how to find first and second derivatives implicitly. Okay, so let's take a look here. So what actually we're going to do when we try to find the first derivative implicitly? So for example, if you have an equation like this kind, and if you try to solve y in terms of x, so which means if you try to find a derivative explicitly, it's going to be very difficult because it's hard to find the y in terms of x there. So that's the reason we try to find the derivative implicitly. Okay, let's take a look how we're going to do it. Remember, when we try to find derivative implicitly means we consider y is a function of x, means you consider y depend on x. You consider y depend on x. The reason here, you see this, we use dy dx. That's reason because sometimes if you just use y prime, a lot of time when these two variables put together, people forget, say, oh, the derivative x is 1, the y's derivative also equal to 1. That is not true. Okay, the y prime is dy dx. Okay, the reason we try to use this, and I explain this as the following. Take a look. If you consider this as a fraction, numerator denominator, obviously that's numerator denominator are not the same. If they are not the same, you can't say that equal to 1. You can't say that's equal to 1 there. Okay, so that's the reason we prefer to use dy dx instead of the y prime. But if you really know the y prime is not equal to 1 and it is equal to dy dx, if you want to use y prime, which is fine. Okay, so now let's take a look how we find dy dx for this equation. Okay, so here, what we try to do here, we differentiate this equation both sides. Okay, so since this is a constant, so its derivative is 0. Okay, so now what we try to do next here is we want to find the derivative for that thing here and that thing here, because this is a product of two functions. So that means when you take derivative each of them, make sure you use the product rule. So here we have d dx x squared y plus d dx y squared x, okay, equal to 0. So now this we use product rule. So here we have derivative x squared times y plus x squared derivative of y, and that's first term's derivative according to product rule. The second term, y squared x derivative y squared times x plus y squared derivative of x equal to 0. Because you take derivative x squared, you take derivative with respect to x. This is just like regular derivative, x squared's derivative, which is 2x, and times y. The x squared, the derivative of y, and as I mentioned, derivative of y, because you take derivative with respect to x, y depend on x. So that means dy dx, if you treat this as fraction, dy dx obviously not the same. You can't say that's equal to 1. So this is dy dx. Quite often people get this part wrong, say, oh, dy dx also equal to 1, because they just say, oh, y prime is what, 1. And because you take derivative with respect to x, if this one, so if you have a dy and y like this, you take derivative with respect to y, so this equal to 1. Okay, if you take derivative with respect to x, this not equal to 1. Okay, so now we got y squared. Y squared. If now you actually need to consider use so-called generalized power rule, because you remember you have ux raised to n, its derivative equal to n u raised to n minus 1 u prime. So now the y is the u. The y is the u. So when you use generalized power rule, you're going to have 2 and y, okay, because that's n minus 1, 2 minus 1, and y prime, okay, that means u prime, which means this case is y prime. But we prefer use the y prime as dy dx. Again, don't consider that's equal to 1. Y squared. The dx, this consider that's equal to 1. That's regular derivative. Okay, so now you can see here we have these two terms contains dy dx, because we want to find dy dx. So here means I need solve the dy dx. Now I'm going to write here. Okay, I'm going to write here. So I put these two terms together, and these two terms, I move this to the other side. So that's two terms because both term contains dy dx. So you factor out dy dx. So dy dx x squared plus 2yx, I just write 2xy, equal to this term, you move to other side, you get negative 2xy minus y squared. So now I need to find dy dx. All I need to do is just use this to divide both sides. I have dy dx equal to negative 2xy minus y squared divided by x squared plus 2xy. So now you find the derivative of the y, but when you try to find implicit differentiation, you find dy dx. So your answer contains both x and y. Okay, both x and y there. Okay, so don't say, oh, look here, what do we have here? What are we going to do to the y? When we do implicit differentiation, the answer normally always contains both x and y there. Okay, so that's the first one. So now let's take a look next example. This example here is we want to find equation of a tangent line to the graph at a given point. Okay, so here that's a point, satisfy this equation. And if you look this graph actually, and it looks like this here. Looks like this here, okay. So we try to find the x equals negative for 2 square root of 3 somewhere here. We want to find a tangent line here, okay. But remember, it doesn't matter what. Find a tangent line, you need to find slope of the tangent line. Okay, you need to find slope of tangent line. That means for this case, we want to find dy dx at negative 4 2 square root of 3. So means we need to find dy dx at negative 4 and 2 square root of 3. We need to find what is this. This is the slope at this point. Okay. So same as before, we differentiate both sides of the equation. D dx x squared y squared minus 9x squared minus 4y squared equal to a zero derivative anyway, that's 0. So I don't need to write d dx, okay? And that's equal to 0. And also here, and I need to take derivative to each of these terms. So I have a d dx x squared y squared minus and 9 and d dx x squared minus 4 d dx y squared equal to 0. Same as before, since this is a product, so you have to use product rule. Okay, so the product rule, so here x squared derivative first times y squared plus x squared, then y squared's derivative. And minus 9, x squared derivative, take derivative with respect to x, so that really is just give us 2x. And minus 4, the y is yx, y depend on x. So when you take derivative for this case, like what we did earlier, you have to use generalize the power rule, or say the chain rule. So you're going to have 2y and the derivative of the y. Okay, so that equal to 0. Now here, let's give us 2x y squared, and that's plus x squared times 2y and dy dx, like what we did like this part, minus 18x minus this 8y dy dx. So now I need put these two terms together because we want to solve dy dx. Okay, so here we put these two terms together. We move everything else not involving dy dx to the other side. So here, since the dy dx is a common factor, so I factor out the dy dx. dy dx 2x squared y minus 8y, and these two things move to other side. I get 18x minus 2xy squared. Okay, so finally I need find what is dy dx by dividing 2x squared minus 8y. Okay, so here I have dy dx equal to 18x minus 2xy squared divided by 2x squared y minus 8y. And remember, what we try to do is find the tangent line at this point. So this is derivative of the function, but in order to find slope, we have to find the derivative at that specific point. It means I need substitute x equals negative 4, y equals 2 square root of 3 into the function and simplify to get the slope. Okay, so here a dy dx, okay, at negative 4, 2 square root of 3, so equal to 18 times x, which is negative 4, minus 2 times negative 4, y squared is 2 square root of 3 squared, 2 times x squared, which is negative 4 squared, y is 2 square root of 3, minus 8, and times 2 square root of 3. Okay. So now, let's simplify this part. Let's simplify this part there, okay? So that equal to numerator, 18 times negative 4, negative 72. This double negative, that's a positive, 16. That gives us 16. 16. this 2 square root of 3 after square, that's 4, that's 3, that's 12. Okay, so that is plus 16 times 12. 16 times 12. Denominator, so here I have negative 4 squared, which is 16, positive 16 times 2, okay, which is 32, and times 2 square root of 3 minus, and that's 8 times y, which is 2 square root of 3, which is 16 square root of 3. Okay, so now let's simplify. So here, 12 times 16, which is 192, then subtract, add negative 72, so which we have 120. Denominator, so I have a 32 times 2, this is 64 square root of 64 square root of 3 minus 16 square root of 3, which is 48 square root of 3. Okay, so now I can reduce some common factor. Okay, and so let's take a look here. And if I reduce by 12, that's going to be 10. That's be 4 square root of 3. Then I reduce further by 2. That's a 5. Okay, and that's 2 square root of 3. Okay, so that's give us the slope. Give us the slope there. And now, what do we try to do here? Okay, this is the slope. So now I want to write the equation of the tangent line. So here I have y minus 2 square root of 3 equal to slope 5, 2 square root of 3 x minus negative 4. Okay, this is so-called slope intercept, a slope point form. Okay, a point slope form there. And if you want to write a slope intercept form, you can just distribute, then move this to other side, then simplify there. Okay, so you can do that. But normally on the paper, point slope form is perfect fine there. Okay, so that's what we have here. Okay, and how to find the tangent line. The main thing here obviously is how to find slope at a specific point when you have implicit differentiation there. Okay, so the last thing here we have here is how to find a second derivative implicitly in terms of x and y. This one is quite often, this is a problem. A lot of time students make a mistake for this case. So what do we try to do? In order to find a second derivative, you have to find the first derivative first. So what do we do here? We differentiate both sides as always. I take derivative to each of them. Okay, so this constant derivative is equal to 0. So that's xy. That means I still need to use product rule. So here I have d dx x y plus x d dx, that's y, and equals 2x derivative with respect to x. That's just simply 2. The y squared derivative is 2y and dy dx. Always remember dy dx is not equal to 1, or y prime is not equal to 1 when you do implicit differentiation there. Okay, so now you can see that equal to 1, so you have y plus x dy dx equals 2 plus 2y dy dx. Okay, so here because you want to find dy dx first, so let's take a look here. Say I move this term to that side, move this to that side. So you can see I have x dy dx minus 2y dy dx equals 2 minus y. And now I factor out dy dx, I get x minus 2y equals 2 minus y. Now I try to find dy dx equal to both sides divided by x minus 2y. So 2 minus y, x minus 2y. Okay, so that's we find the first derivative, but we want to find a second derivative. Now, how are we going to find the second derivative? Remember, second derivative is the derivative of first derivative. Means I'm going to take derivative one more time for this dy dx. Okay, so now I'm going to use so-called the quotient rule because this is a quotient of two functions. I'm going to use quotient rule. When you use quotient rule, so here you're going to write this here, and the numerator take derivative first times denominator minus numerator and the denominator's derivative and the denominator's squared. That strictly follow the so-called the quotient rule there. Okay, so now I'm going to finish the quotient rule here. So that 2 or minus y derivative, 2's derivative is 0. So that means that negative y derivative is just simply give you negative dy dx. And x minus 2y minus 2 minus y. And the same thing here. The x minus 2y's derivative and x derivative is 1. 2y's derivative 2. Y's derivative just simply write dy dx. Okay, divided by x minus 2y squared. Okay, so now what I do here, remember when we solve this here, it says we're gonna write dy second derivative implicitly in terms of x and y. Means your answer cannot contain dy dx. Cannot contain dy dx there. Okay, so what do you do here? All you need to do is just replace dy dx by what you have there. So that equal to negative 2 minus y x minus 2y minus 2 minus y. Oh, this here x minus 2y. I forgot this one here. And 1 minus 2. And the dy is 2 minus y x minus 2y. And the denominator is x minus 2y squared. Okay, so here you can see x minus 2y, you can reduce that. So you're going to have this negative 2 minus y only because that's reduced. You only get negative 2y left, minus 2 minus y, and 1 minus 2 times 2 minus y, x minus 2y, and divided by x minus 2y squared. Okay, so now the rest of the thing here obviously is just go ahead to simplify. Okay, simplify there. Okay, and so now let's take a look at how we're going to simplify this here. Since you have that thing here, I'm going to combine this together. So here, this you can see the one because the common denominator is x minus 2y. So here you're going to write x minus 2y and x minus 2y, which is 1, minus 2 minus y, x minus 2y. Okay, so here, now you just combine this together. So what you have here, you see, I got minus 2 minus y minus 2 minus y. Okay, and so here, this together, you can see here, I have x minus 2y and x minus 2y minus 2 times 2, which is 4. 2 times this, you see, double negative, that's plus 4y. Okay, so that's what we have here. You have x minus 2y squared. Okay, so now all you need to do is just rewrite that, simplify. You can see this negative 2y is positive 4y. You can see you got x minus 4 minus a plus 2y. Okay, because that's x minus 2y, 4y, and minus 2y, so which is positive 2y there. So finally, you have negative 2 minus y minus 2 minus y, and x minus 2y, x minus 4 plus 2y, and divide by x minus 2y squared. So now all I need is just simplify this part. Okay, so here you can do combine them together, or you can just both numerator denominator multiply x minus 2y there. Okay, so which means you multiply x minus 2y to the numerator and the denominator. So you can see you get negative 2 minus y times x minus 2y minus 2 minus y. Okay, because you multiply x minus 2y, so that's canceled. You have x minus 4 plus 2y and divide by x minus 2y. Because numerator, denominator both multiply x minus 2y, so that's going to become cubed. Okay, so now all you need to do next here is, since you have common factor 2 minus y, so you factor, or you say negative 2 minus 4y, 2 minus y, so you factor out 2 minus y negative. Got x minus 2y plus, because you factor both negative, plus x minus 4 plus 2y, divided by x minus 2y to the third. Go ahead, cancel this. So you have 2x minus 4. So you get negative 2 minus y and 2x minus 4, x minus 2y cubed. So that is your second derivative. I know this is a kind of long, so here, but that's how we do it. Okay, and quite often people get to that step, then stop. Says, "Oh, I'm done." Not done yet, because you have to rewrite the y dy dx in terms of x, y. So that's the reason we do the following. The rest of them just simplify the function there. Okay, so that's it for this part. Okay.